Good morning, the Council. Welcome to the thesis defense of the major automatic and control engineering technology in the Faculty of High Quality Training. I'm very pleased to stand here to present our project, design, implementation, and control of the Hexapod. I'm Minh, and this is my partner Huynh. Today we're together to perform our project. Thanks to our advisor, without his direction, we can accomplish this project. And our presentation is divided into the four parts, corresponding to the four modes of the robots operation. And all the D parts is under the robot kinematics algorithm and the simulation. We come to the first one, the introduction. Nowadays, everywhere we are, we hear so many strange concepts to the ordinary people. That's about the big data, the deep learning, artificial intelligence, etc. That's because we are in the fourth industrial revolution. That's about the automation and global connectivity, where the main cause of the whole revolution is autonomy system. So, therefore, the research on the robots and its application is increasing the productivity, transportation, or even rescuing is being promoted. So we brought up the topic of design the six-leg robots, or formerly known as the Hexapod. To assess the effectiveness of the robots model, we put three main objectives to these robots. The first one, the robot will be stable in movement, and the robots will be easily to address by everyone, and the robots will meet some practical requirements, And before initiating the presentation content, we include 18 joy. And the parameter of Hexapod is corresponding to the table on the right. Upper half is the dimension of body, and lower half is the dimension of length. The first is the lin 1 is Cosa, and lin 2 is Phung, and lin 3 is Tipa. And continue, I will present the power kinematic. We created a single coordinate in the image, and we created a table data for DS table. Yeah, icon is dynamic table. In the table, there are angle of two links, and the link length distance, and the link length, and the twisting angle. And the yield parameter in the table substitute into the conversion matrix. And I calculate the endpoint coordinate of the singlet. We obtain the S, Y, and G0. And from it, the result.
I think for this one, we should give the pointer.
Yes.
The laser pointer. This is easy for the teacher.
Yes.
Can follow what you doing, what you talk. Okay.
Yes, thank you. And from this endpoint coordinate, yes, I calculate theta for the segment length. I calculate theta 1, theta 2, and theta 3 so for each length. And from the inverted method to transform the new position to the angle rotation. And with my lab simulation, I apply the forward kinematic, and we have to, if I want to move the robot, I have to update the new location, and after invert kinematic to transform become angle rotation and conduct the simulation. The final we gain the graph of the robot's movement.
Okay.
And with the simulation, I get the final, the first I apply the kinetic, and the second I apply the new position, and the third we apply the invert kinematic and conduct a simulation. In the simulation, I draw the movement for the mass operation, the first and the second and the third. Come to the manual mass, I can control the robots through the application to connect the Arduino to control the 18 servo. Yeah, thank you.
Not always does the robots move on the flat terrains. In some time the robots have to move on the slope terrains or on the route. So to keep the robots balancing, we use the gyroscope sensor to read the angle, the body angle, and in the diagram below we can see the reference is the set point that we set for this robot. And after we read the measure output from the sensor, we calculate the measure errors to the controller to keep the robot balanced.
So what kind of the controller you use for this?
And yes, we use the
DID or anything else? What kind of controller?
yes, the controller is the Azure microcontroller. Yes, and we can see on the right side. Right side we have the two graphs. When we assess the effectiveness of the sensor, the first one, when the robots adapt,
I think maybe some teacher they can ask about this one. What kind of controller to control your system? So you have to explain about this one. So you have to think about this. What kind of controller you use to control your system? So maybe someone will ask you about this.
I guess the controller we write not in a standard control like the PID or the command that we write absolutely yes by the coding.
But remember this.
Yes,
Okay.
thanks. And we can see the first one when the robots adapt the balance on the terrain, and the second when the robots adapt the balance on ground. So by the way, when the robots stand on a flat ground and right way, I will perform this balancing mode. And we come into the tracking mode. The tracking mode gives the robots ability to visualize surrounding environments, and this content will be performed by our partner.
And the common tracking mask, I use the image processing. In the first, I use change the color sprite. In the image, I use RGB image, and I will transfer RGB to SUSB. In the ones, the RGB is the U in the image, and SSB in the Android. And 3, the SV is the U for the Android Studio, and two value is different. And why transfer RGB to SSB because I can evaluate detect accuracy about 90%. And on the right side, it's a mathematical equation evaluate the
Okay,
conversation.
for this one, maybe some teacher will ask you about why we use another model of the color, just we use SSB, why we don't use the RGB color.
Yes.
So you have to remind about this one in your mind to answer this question.
Yes.
Okay?
Thank you.
Why? what we have to transform from the
This,
RGB.
you remind in your mind.
Oh, thank you.
Okay, prepare this
I
one.
remember your opinion, and I will continue. And the tracking marks and the colors by the first and the second are on the image. And from data, I will control the robot balancing and tracking the object on the image. And I will begin the pass. This is a result by image processing. The first, this image captured from the on-camera Android Studio on I use the app. And second, I transform to the pixel image. And third, I use the morphology is the indexing and deleting to remove the noise and the hole in the image. And the final, I use the Gaussian node to make the image clearly and full the circle on the image to detect the center and radius is very good.
At this point, maybe some teacher will ask you about how many colors you can detect
Yes.
and how you can separate. This one is green, this one is blue, this one
Yes.
is red. So you have to think about this to
Yes.
answer this question. Okay.
The problem is solving the.
No answer here.
Yes,
Okay,
thank
about
you.
this.
I remember thank for your opinion. And the track is in the circle hard transform is very important to detect the circle in the final step in the image processing. In the input, I will add detector. The image is area is very big, and I will transform to the small image with the circle. Is the add
At this
detector.
point, maybe some teacher will ask you about there are several of the methods to do the edge detection. For example, surveil,
Yes.
Kenny.
Yes.
So why you use a hot transform to do this one? So remember this in your mind to answer this question.
Yes. I understand the you. And the second idea then for the parameter the representation, and the first I use the calculator, and the final I collect our circle detect in the image. Yes. And on the screen is the tracking. I detect the area and the center of the image, the circle. On
This one is the object.
yeah,
The object.
yeah, thank you.
We detect the object, the center of the object.
We detect the object with the balloon. Green.
This one ring.
Green, that's green, and it's very effectively. I draw a rectangular boundary around the project to be detect. And the file rainbows I will be present by Mr. Minh, and I invite you to present with the council.
So I think we should reserve time for talking this session.
Yes,
This will take so long time for you right
yes,
now. Okay.
I will review.
Because most of the teacher they want you focus on what you do.
Yes.
For this project.
Yes, okay.
Actually, after this slide, I will perform this. Yes. This is our screen. For example, I have object. Yes, we don't have a brown object right here, and we touch on the screen, and after that we choose the color of this screen. For example, we choose this one, and now. Yes, and if we got a brown sharp table, a brown sharp object, and this will be performed effectively, like this. Okay, and we can choose anyone from this another object. That's in the basement that we want to build a flexible image processing on the other version.